Hello guys, what's up? Welcome back to my channel once again, and in today's video we'll be focusing on one of the most crucial and most important and effective solution for many of competitive questions which you'll be getting in most of the companies like Google, Amazon, Facebook, Flipkart, Walmart, and the list goes on. So without any further ado, let's get started. Let's try to figure out what is a binary search. Basically, it's a searching algorithm technique. For example, you'll be just provided with certain kind of like array list, vectors. You'll be asked to figure out or to find out the element that will be lying in this array or array list or input array, whatever you could be given. So why would be just going for the binary search? Let's try to figure. So basically, it's the most efficient, effective, and the optimal way for finding an element on a shorted array list, or a vector. You need to remember this term, shorted. All the elements in that array or array list needs to be in a shorted order. So that's one of the, you could say that it's a prerequisites of the binary search algorithm technique. So how it works? So the working criteria of binary search algorithm is completely simple and easy to understand. It's gonna split your entire array into two pieces, okay, with a mid index. The element which you will be searching for, it will be looking into the left half and the right half iteratively. So if it will be just figuring out that element, it will return you the element. So that's it. So why definitely the binary search? Sometimes in most of the companies like the top-notch product-based companies, they will be just focusing on those solutions which will be the most optimal, time-effective and space-effective solution. So in that case, binary search plays a crucial role. So how it works? So basically, it's the fastest way, you could say the most optimal and the most fastest way. The time complexity for this algorithm is big O of log n. So how it's the fastest way? As I've already told you that it's gonna split your array into two halves, left half and the right half. Your array needs to be in a shorted manner. So just try to understand that if your array is in a shorted manner, so the left half up before the mid part, before the mid index, all the elements to the left side definitely needs to be smaller than the mid index, and all the elements to the right side is supposed to be greater as compared to the mid index. So you must be getting the point. Normal thing that if you'll be getting an array of elements of 10 elements, then definitely the time complexity, if you're just using a linear search going through each and every element, you'll be getting big O of n. That's 10. Big O of 10. But you'll be getting 10 raised to 3 elements. That's 1000 elements. So if you are just going on with a linear search, so it simply sucks at that time. At that time, things just got out of hand. You know better. The time complexity will be definitely reduced in case of binary search algorithm. So that's one way. And the next way is that definitely being a coder, and you'll be looking out for something that will be pretty much easy and convenient to code out. So at that point of respect, you must go out for a binary search algorithm. We are done with enough talk. Let's start coding. With this, let's start with yes, not Java.
One eternity later.
So we are done with the code, and let's try to understand this code. This is an array. Okay, so we are taking certain values. Let's assume this is the array, and we are taking certain values like 12, 23, 44, 56. So and the last element, let's consider it's 77. Okay, and the key value that we are searching for is let's say it's 56. Okay, so what we do in binary search is taking two pointer, low as 0 and high as the array length minus 1 means 0, 1, 2, 3, 4. So 5 minus 1, that's 4. Okay, let's try to figure out the mid. Mid gonna be 0 plus 4 by 2, that will give you 2. Got it? So then our mid index is at 2. Okay, what's the element at mid index? It's 44. So we'll be trying to first check with the base condition. Okay, you must remember what's the base condition right here, that we'll be searching for is, the first thing is that while low is less than equals high, yeah, definitely our low value is 0 and the high value is 4. Low is less than equal to 4. So the next thing is that we just figure out the mid by just doing this kind of operation like low plus high by 2, and now we'll be just checking the base condition that if a mid equals key or not. Is our a mid value, that's 44, is equal to key? Definitely not. Okay, it's not equal to key, but instead it's less than key. 44 is less than 56. What does it mean? It's in a sorted array manner. So our key value which we are searching for is lying in the right half. So why will be bothering about the left half? So that's the place where the code is simplifying the time complexity. So I hope you must have got it. So now we'll be just looking out for this, but we need to shift the pointer to the right half as well. So what we need to do is we need to change the low pointer, the lower pointer, to mid plus 1, that's 3. So now the thing will be shifted from this won't be the mid anymore. Okay, 44 won't be the mid anymore unless we'll be just focusing on 56 as the mid. Okay, the mid index is the 3. So now we'll be trying to figure out the mid as, once again, as low is less than equals 4, low is less than equals high. So once again we'll be trying to figure out the mid value. So that's 3 plus 4 by 2, 7 by 2, that's 3. Okay, so now once again we'll be trying to figure out that if a mid equals key or not. Is it equals? Yeah, we are getting 56, that's equal to the key value. So that's it. How many iterations we have highly covered. So it's pretty much simplified and easier to understand and to code out. We'll be just giving the same input and try to figure out whether it's running or not. Java binary search. Okay, so there are five inputs, elements 12, 23, 44, 56 and 77. So that's it. Let's search for the value which we are looking out for is the 56. So 56 is available at index 3. It's definitely great. So here we have simplified the code as well as we have reduced the time complexity to a higher context. That's it for today, guys. Hope you enjoyed the video. If you like this video and if you found this much more helpful for you guys, do leave a like. Feel free to leave a comment from your side. I love to read your comments. If you are new to this video, don't forget to subscribe to my channel. Stay tuned for new videos. Till then, bye bye.